Today I'm going to review some of the rules for exponents. I think most of everybody had this last semester, but I just wanted it in a new spot. So the rules for exponents, there's 6 of them. So the first rule is if we have the same base and we're multiplying, we add the exponents. Rule 2 is if we have same base and we're dividing, we subtract the exponents. Rule 3, if we have two things and one is raised to a power, then we multiply the powers. Rule 4, if we have a product raised to a power, you take each one of those things to that power. Rule 5, if we have a fraction all raised to the power, then we take each one of those to the power. And again, these will be a different base. And then rule 6 is if we have something to a negative power, that's the same thing as 1 over a to the positive power. So I'm going to give you a couple practice problems, and you'll use these notes to use your practice. You can also find these in your book on page 420. They are also in your book. Let's look at problem number 1. What you want to do is you want to treat numbers like you're multiplying. So I sometimes will have students rearrange the numbers and then the variables. 3 times 2 is 6, and n to the 4th power and n to the 1st power. This should look like rule 1 to you. Same base. We're going to add the exponents, and 6n to the 5th will be the final answer. So try number 2. Put the 2 and the 4 together, the b squared and the b squared together. So take care of numbers where we multiply, and when we're multiplying bases, we add the exponents. Think of these as separate. So 2 over 4 reduces. What happens to x over 4 and x cubed? This should look like rule 2. So we're going to subtract the exponents. X to the 4th, x to the 3rd, reduce 2/4, we get 1/2. 4 minus 3 is 1, and typically we will not write that 1. Sometimes it's easy to see the rule if we write out what n to the 4th means. And anytime that we have the same variable on the top and the bottom, we can get rid of it. Another way to think of this is 4 minus 1 would give you an n cubed. What do you do with that 2? It remains on the bottom. 5 and 6 are powers to powers, so this should look like rule 3 to you. If we have something raised to a power, we multiply these powers. But wait, if we have 2 things raised to a power, it should look like rule 5. 2 things raised to a power, take each one of those to that power. So in number 5, we would take 4 cubed, and squared cubed is a power to a power. So 4 cubed, if you take your calculator out, 4 cubed is 4 times 4 times 4. On these calculators, you will punch out 4, and then the power button is this caret. So the caret will appear. If you see this arrow key, you have to hit the over key and hit enter, and then you'll get 64. So final answer to number 5 will be 64. Power to power, we multiply those powers and get n. I should write that n to the 6th power, like that. Here we have two things raised to the fourth power, so we take 2 to the fourth and k cubed to the fourth. Again, 2 to the fourth is 2 times 2 times 2 times 2, if you don't know that. Using your calculator, 2 raised to the fourth power, that'll give you a 16 power to power. We multiply the powers. The last section we're going to deal with negative powers, and our final answer, we're going to make sure that they go in positive powers. So first let's use our rules. So if we have multiplying, let's put our numbers together. So 4 times 4, and then again if I have p to the negative 2, p to the second, p to the negative 1. Let's take care of numbers. 4 times 4 is 16, and then if we're multiplying variables together, we're going to add the exponents. A negative 2 plus 2 is 0, and 0 plus a negative 1 is going to be a negative 1. Now, how do I rewrite that? 16 is my number, but p to the negative 1 power, anything p to the negative power means the same thing as that to the power in the denominator. So p to the negative 1 would be p to the positive 1. Power to a power, number 8. A negative 2 times a negative 2 is a positive 4, and I would be done with that problem. Number 9, we have two things raised to a power, so the first thing we have to do is take each one of those raised to the power. A negative 2 times 4 is a negative 8, and then we're going to rewrite that so we have positive exponents all the time. So again, we'll use our calculator probably to find 3 times 3 times 3 times 3, or 3 to the 4th equals an 81. And notice that is a positive power, so that'll be an 81. X to the negative 8, we write that as 1 over x to the positive 8. And number 10, you'll be asked to take care of numbers first. There's a number here, so 1/4 is just 1/4. Now be careful when you subtract exponents. A negative 2 minus a minus 4. A minus minus, remember, is a plus plus. So this would give us an n. Negative 2 plus 4 will be a positive 2. You might also see that written as 1 times n squared is just n squared all over 4. The last example that I'll do with you together is take care of numbers. 2/4 reduces to 1/2. And again, since we have same bases, we subtract the exponents, and negative 2 minus a minus 4 is an x squared. This and this are the same thing. So what I'd like you to do is to go over your notes, hit stop, play, rewind. I have some practice problems for you to do, and please ask any questions if something doesn't make any sense.